Alright, boys and girls, welcome to video 11-3, the areas of circles, sectors, and segments. Let me remind you to have your note packet open and your book open when you're looking at these videos. First of all, let's review. The area of a circle is pi r squared, and the area of the sector is the piece of that circle. So it's going to be the central angle over 360 times the area of the circle. Central angle over 360 is a fraction times the circle pi r squared. Well, let's do some. Find the area of the sectors below. The first one. Our central angle is 45 over 360. That equals 1/8 times the area of the circle. 100, 10 squared, pi. That then equals 108 pi, which equals 25 over 4 pi. There's our answer to the first one. Let's work on our second one now. We have a central angle of 135 over 360. That reduces to 3/8 times the area of the circle. Our radius is now 16. Our radius is 4. 4 squared is 16 times pi. I can cancel my 16 and my 8 and get 2. This final answer is 6 pi. Why don't you try these? Okay, the answer to letter A was pi. The answer to letter B was 147 over 8 pi. The answer to C was 9/2 pi. And the answer to D was 2 pi. And last but not least, our answer to E was 50 pi over 3, or 50/3 pi. And our answer to F was 4 pi. Now let's talk about a segment. A segment is a part of a circle. It's actually part of a sector. It is the region of the circle that is bounded by an arc length, right here, and by a chord. A chord is a line that goes from edge to edge of a circle. As you can see, the area of that segment is going to be the area of the sector. That's this whole piece right here. Take away the area of our triangle right here, and what we got left is our segment. Okay, let's find the area of this segment right here. It is going to be the area of the sector. So I'm going to have my central angle, which in this case, notice that my arc length was 90, which means my central angle is also 90, or a right angle. So my central angle is 90 over 360, which equals 1/4 times the area of the circle, which is pi, times the radius squared. In this case, our radius was 2. 2 squared is 4. 1/4 of 4 is 1. So I have the area of my sector is pi. To find the area of my circle, I need to do 1/2 base times height. Notice that my base here is 2. My height is also 2. It's nice when we have a right triangle. So the area of our triangle is 1/2 the base, which is 2, times the height, which is 2. 1/2 times 2 times 2 is 2. So therefore, the area of that segment is going to be pi, the area of the sector, minus the area of the triangle, 2. And there is our final answer. Let's do one more here. I got a segment with point P as its center. First thing I'm going to do is I'm going to draw in my radii. Okay. I notice that my arc length, again, is 90, which means I have a right angle of a central angle. My central angle is going to be 90 over 360. I'm looking for the area of my sector right now. That, of course, is 1/4 times the area of the circle, my radius was 12. So therefore this is 12 squared, which is 144 times pi. The area of my sector is 1/4 of 144, or 36 pi. My triangle, its area is 1/2 the base, which in this case is 12, times the height, which is 12. 1/2 times 12 times 12 is 6 times 12, which is 70 dose. The area of my sector, segment is going to be 36 pi, the area of the sector minus the area of the triangle, 70 dose. All right, this one's going to be a little bit tougher because we do not have a right triangle. Notice that my radius is 8, and I have a central angle of 120. So the area of my sector is going to be 120 over 360, which equals 1/3, times the area of my circle, which is the radius squared, times pi. So the area of my sector is going to be 1/3 times 64, which is 64/3. Don't make this harder than what it is. Pi. 64/3 pi. Now we got to find the area of this triangle. Well, I have a base of 8. I do not have the height yet. The height has to be perp to the base. Well, pretty cool here. What I have just drawn is a 30, 60, 90 right triangle right here. Because if this is 120, that means this angle right here must be 60. So using what we know about 30, 60, 90 right triangles, if the hypotenuse is 8, this side would be 4, and the height now is going to be 4√3. So the area of my triangle is 1/2 times the base, which is 8. That's the base right here. Times my height right here. That's 4√3. Therefore, the area of my segment is going to be the area of the sector, 64 pi over 3, minus 1/2 of 8 is 4, times 4 is 16√3. Voila! Okay, let's just do one of these weird shapes, kind of help you out and figure out what's going on. We need to find this shaded region, and we don't have a formula for that kind of Nike sign that got stretched a little bit. However, let's kind of take a close look here and notice that what I have is I have a large circle with a radius of 3, and all these are equal. So this is 3, 3, and 3, and that radius was 9, not 3. Okay. If I look here, I notice I have a half circle, and I can actually move this shaded region. And do you see that what I have here really, in essence, is a not large, but medium-sized green circle. Then, notice I also have a little circle, and a little half circle right here, and I can slide this half circle, A. But you can see now I have a medium-sized circle minus a little circle. The medium-sized circle has a radius of 6, and my little circle has a radius of 3. So, the area of my shaded figure is the area of the big circle, pi r squared, r was 6, minus the area of the little circle, pi r squared, r was 3. So this becomes 36 pi minus 9 pi, which equals 27 pi. And that is the area of our shaded region that we see right